Alternating current. Alternating current is that current whose magnitude changes continuously with time and direction reversing periodically. As the alternating current is positive in one half cycle and equally negative in other half cycle, its mean value over a complete cycle is 0. So, we can measure alternating current in terms of its mean value over half cycle or its root mean square value over a complete cycle. Mean or average value of alternating current. It is defined as the value of direct current which sends the same charge in a circuit in the same time as sent by the given alternating current in its half time period. Since I equals dq divided by dt, the charge flows in time dt is dq equals I dt. But we know I equals I0 sin omega t. So dq equals I0 sin omega t into dt. So total charge flows in half cycle is q equals integral dq equals integral limit 0 to t half I0 sin omega t into dt. Since I0 is constant, q equals I0 integral 0 to t half sin omega t into dt. After integration, q equals I0 inside the brackets minus cos omega t divided by omega limits from 0 to t half. After rearrangement, q equals minus I0 divided by omega cos omega t 0 to t half. But omega equals 2 pi divided by t. Thus q equals minus I0 divided by 2 pi divided by t into cos 2 pi divided by t into t limits from 0 to t half. After applying the limits, q equals minus I0 t divided by 2 pi inside the bracket cos 2 pi divided by t into upper limit, that is t half, minus cos 2 pi divided by t into lower limit, that is 0. Thus q equals minus I0 t divided by 2 pi into cos pi minus cos 0, which is q equals minus I0 t divided by 2 pi into minus 1 minus 1, which is minus I0 t into minus 2 divided by 2 pi. So q equals I0 t divided by pi. Mean value of AC in half cycle is Im equals q divided by t half, which is I0 t divided by pi all divided by t half, which equals 2 I0 divided by pi. Root mean square value of alternating current. It is defined as the value of steady current or DC which passed through a given resistance for a given time will produce same amount of heat energy as produced by an alternating current when passed through the same resistance for the same time. Heat produced in time dt is dH equals I square R dt, but I equals I0 sin omega t. Thus, dH equals I0 sin omega t whole square into R into dt, which is I0 square sin square omega t R dt. So, heat produced in full cycle is h equals integral dh equals integral 0 to t I0 square sin square omega t r dt. Since I0 and r both are constants, h equals I0 square r integral 0 to t sin square omega t into dt. But sin square omega t equals 1 minus cos 2 omega t divided by 2. So h equals I0 square r integral 0 to t inside the bracket 1 minus cos 2 omega t divided by 2 into dt. Take 2 outside and apply integration for 2 terms. Then h equals I0 square r divided by 2 integral 0 to t dt minus integral 0 to t cos 2 omega t dt. Since the second term of the integration is 0, h equals I0 square r divided by 2 integral 0 to t dt. After integration, h equals I0 square r divided by 2 into t limits from 0 to t. After applying the limits, h equals I0 square r divided by 2 inside the bracket t minus 0, which is h equals I0 square r divided by 2 into t. But heat produced in terms of RMS value, h equals IRMS square RT. After comparing equation number 1 and 2, we get IRMS square RT equals I0 square RT divided by 2. After solving it, IRMS equals I0 divided by root 2 equals 0.707 I0.